Hello, this is Ashwin. In this video, I'll be solving paper 4, variant 3, May June 2018, 0620 chemistry. Starting with question number 1, the following are the symbols and formulae of some elements and compounds. Answer the following questions using only the elements or compounds in the list. Each element or compound may be used once, more than once, or not at all. State which element or compound is used. A, to kill bacteria in drinking water. So chlorine is used for treatment of water, and so this is going to be chlorine. B, as a food preservative. So sulfur dioxide is used to preserve a dry food. So here we have sulfur dioxide. C, as an electrical conductor in cables. And that is the metal over here, which is copper, since this is relatively cheaper to attain and a good conductor as well. D, as an inert atmosphere in lamps, which is argon. E, to neutralize excess acidity in soil, so a base over here, which is calcium hydroxide. F, as a catalyst in the contact process, so this is vanadium oxide. Question number 2. Aluminium-29 is a radioactive isotope of aluminium. The only non-radioactive isotope of aluminium is aluminium-27. 1. Describe in terms of protons, neutrons, and electrons how the isotopes of aluminium-29 and aluminium-27 are similar and how they are different. So they are similar in terms of their protons and electrons. And they have different number of neutrons. To complete the table to show the number of nucleons, neutrons, and electrons in aluminium-27 ion. Alright, so nucleons is the number of protons plus the number of neutrons, or the mass number, which is 27. Neutrons is when you get the number of neutrons by subtracting the atomic number or the proton number from the mass number. So 27 minus 13 is 14. And electrons. Alright, so normally aluminium has 13 electrons. However, since this is an ion, it has a charge of 3 plus. That means it has lost 3 of the 13 electrons. So now it has only 10 electrons. B, aluminium is extracted from its ore by electrolysis. 1, name the main ore of aluminium. So the name of the ore is bauxite. 2, why is aluminium not extracted from its ore by reduction with carbon? So to reduce a substance with carbon, it would have to be less reactive than carbon. However, aluminium is more reactive than carbon, so it cannot be reduced by carbon from its ore. Three, the main ore of aluminium contains aluminium oxide. Aluminium oxide is dissolved in molten cryolite before it is electrolyzed. Give 2 reasons other than cost why cryolite is used. So cryolite reduces the melting point of the mixture. And it also increases or improves conductivity. 4, the reaction at the anode during the extraction of aluminium by electrolysis is shown. Is this process oxidation or reduction? Give a reason for your answer. So as you can see over here, this oxygen ion, the oxidation state of the oxygen ion changes from -2 to 0. That means it's losing electrons, which means this is oxidation. 5, during the extraction of aluminium by electrolysis, carbon dioxide is formed at the anode. Explain why carbon dioxide is formed at the anode. So anode, being the positive electrode, attracts the negative ion in the mixture, which in this case is going to be oxygen from aluminium oxide. So oxygen is attracted toward anode, and then it reacts with the carbon in anode to form carbon dioxide. C. When a piece of zinc metal is added to copper sulfate solution, there is an immediate reaction. When a piece of aluminium metal is added to copper sulfate solution, the initial reaction is very slow. 1. Explain why zinc metal reacts with copper sulfate. So again, this is a displacement reaction. As you can see, zinc displaces copper from copper sulfate to form a zinc sulfate and a copper element. And zinc displaces copper because it is more reactive than copper. Two, what type of reaction is this? This is a displacement reaction. 3. Explain why the initial reaction between aluminium metal and copper sulfate is very slow. So aluminium is a relatively reactive metal, so it reacts with oxygen in the environment to form a layer of aluminium oxide on its surface, which reduces the rate of its initial reaction with copper sulfate. Three, cobalt is a transition element. Potassium is in group 1 of the periodic table. A, state one physical property that is similar for cobalt and potassium. So you can write any typical physical property of metal. So I'm going to be writing about the electrical conductivity. B, state one physical property that is different for cobalt and potassium. So cobalt is a transition element and potassium is a group 1 element, which means it has a relatively lower melting point, lower density, and it is softer than cobalt. You can write any one of those. So I'm going to be mentioning about melting point. Describe how the physical property given in B1 is different for cobalt compared to potassium. So cobalt has higher melting point. C, when a small piece of potassium is added to water, the potassium floats and disappears as it reacts. Give two other observations that would be made when a small piece of potassium is added to cold water. Alright, since this is a reaction between a metal and water, hydrogen gas would form, and that would result in the formation of bubbles, which is the observation over here. And also the potassium moves as it reacts. D, cobalt reacts with dilute hydrochloric acid to make the salt cobalt chloride. Bubbles of hydrogen gas are produced. 1. Describe a test for hydrogen. So the test is a lighted splint, and the result is that it burns with a pop. A pop sound. 2. The rate of reaction of cobalt with dilute hydrochloric acid can be made faster by heating the acid or increasing its concentration. State one other way to make the reaction faster. So here you can mention either of the factors affecting rate of reaction other than concentration and temperature. So that can be surface area or catalyst. I'm going to be writing about catalyst over here. 3. Use collision theory to explain how heating the dilute hydrochloric acid makes the rate of the reaction faster. Alright, so increasing the temperature or heating it makes particle gain energy. And more of the reacting particles have enough energy to react. And what this means is the sufficient energy to react is that they have energy greater than the activation energy, since activation energy is the minimum energy that reactants need in order to react. So they need to have either that minimum level of energy or higher than that. And increases the temperature means more number of molecules or greater number of molecules have this activation energy or more than activation energy. or energy more than activation energy, right? And also increasing the temperature increases the rate of collision. When cobalt chloride is added to water, an equilibrium is established. 1. A student adds water to a blue solution containing cobalt chloride ions. Describe what the student observes. Give a reason for your answer in terms of position of equilibrium. Alright, so adding water disturbs the equilibrium, and the equilibrium would shift in a direction which would reverse the increase in water, and that means conversion of water into products, and that is the forward reaction. So the equilibrium would shift to right direction, and that means the color would turn pink, and that would be the observation. Two, another student cools a blue solution containing cobalt chloride. The blue solution turns pink. What does this information indicate about the forward reaction? Right, so the forward reaction is from blue to pink, and if this is, as the question mentions, this is favored by low temperatures or favored by a cool temperature, and a reaction which is favored by low temperatures is exothermic. Another compound of cobalt is cobalt hydroxide. Reduce the charge on the cobalt ion in cobalt hydroxide. Right, so here you need to know about the hydroxide ion. The hydroxide ion has a charge of -1, and as you can see over here in this compound there are 3 hydroxide ions, and that means 3 hydroxide ions give a charge of -3, a total charge of -3. And also you can see over here in the compound there's only one cobalt ion. One cobalt ion. So this one cobalt ion has to have a charge which is sufficient enough to cancel out this -3 and give an oxidation state for the entire compound as 0, because any compound should have a charge of 0. So a charge which is enough to cancel -3 to give 0 is +3, or a charge of 3 plus. Since they cancel out each other, that means one cobalt ion should have a charge of 3 plus to cancel the 3 hydroxide ions, and that is why cobalt has a charge of 3 plus over here. 4. Ethanol is a member of the homologous series of alcohols. A, give 2 characteristics of members of a homologous series. So they have, you can write any of the 2 characteristics. I'm going to be mentioning about the general formula and the functional group. B, the structure of ethanol is shown. Complete the dot and cross diagram to show the electron arrangement in a molecule of ethanol. Show outer shell electrons only. So as you can see over here, there are only single bonds. That means in each overlap of these shells, there is only going to be a single pair. Alright, so here I'll be representing hydrogen with a dot, carbon with a cross, and oxygen with this little circle. Right, so starting with hydrogen and carbon, we have a pair of electrons in each of these overlaps, and since we only have carbon and carbon overlap, there's going to be 2 of these. And then again we have carbon atom and then an oxygen atom, and then since oxygen is sharing 1 with carbon and 1 with hydrogen, it remains with 4 electrons, as it has 6 electrons in its outer shell, and then hydrogen has 1 of its own in the covalent bond, and that's it. Wait, this is a dot over here. C, ethanol can be produced by catalytic addition of steam to ethene or by fermentation of glucose. Write a chemical equation for the production of ethanol by the catalytic addition of steam to ethene. Okay, so we have ethene, C2H4, reacting with water or steam to form ethanol. To write a chemical equation for the production of ethanol by the fermentation of glucose. So you have the reactant being glucose, and then it's fermented to form ethanol and carbon dioxide. And then we're supposed to be balancing the equations. As you can see over here, there are 6 carbon atoms, so you need to balance it over here. So you add 2, and then 2 over here once more. So you have 2 2s are 4, and then 6 carbon atoms, and the rest of the elements balance out as well. 3. State one advantage of producing ethanol by catalytic addition of steam to ethene. You must not refer to the cost. So over here in this process, the ethanol produced is more pure compared to the ethanol prepared by fermentation, so you don't need to run out extra purification processes. For state what advantage of producing ethanol by the fermentation of glucose, you must not refer to the cost. So glucose over here, unlike ethene, is a renewable feedstock. So that is one advantage. The ethanol can be oxidized to ethanoic acid. State the chemical reagent needed to oxidize ethanol to ethanoic acid. So you need the presence of this agent, which is acidified potassium manganate. Ethanoic acid reacts with ethanol in the presence of an acid catalyst. The products are organic compound and water. 1. Draw the structure of the organic compound formed. Show all of the atoms and all of the bonds. So ethanoic acid reacts with ethanol to form ethyl ethanoate. And to draw the product, I'd first like to draw the reactants. You don't have to draw those. I'm just drawing them for my convenience. So we start with ethanol, which is 2 carbon atoms. And then you have ethanoic acid. So the hydroxide group from this acid reacts with hydrogen of this alcohol to form the ester. So in drawing the esters, you draw the acid first and then the alcohol. And that means you draw the carbon. And then you have this oxygen. Now this bond opens up to the alcohol. To state the name of the organic compound formed, so the process of drawing the esters and naming the esters is opposite. For drawing, you draw the acid first and then the alcohol. However, for writing their names, you write the name of the alcohol first and then the name of the acid. But this one over here is not going to be as you can't notice the difference over here, since both of them are ethanol and ethanoic acid, so it will be ethyl ethanoate anyway. 3. Which homologous series does the organic compound formed belong to? So this is an ester. F-ethanoic acid is a weak acid. It reacts with copper carbonate to form the salt copper ethanoate. 1. What is meant by the term weak acid when applied to acid? So weak acid is an acid which only partially dissociates into ions when dissolved in water. To describe how a crystalline sample of copper ethanoate can be prepared, starting with the ethanoic acid and copper carbonate. So this is a reaction of an acid with a metal carbonate, and in this reaction you're supposed to be achieving a soluble salt. In such type of reactions where you're supposed to be achieving a soluble salt from an acid and a metal carbonate, you always start with an excess of the carbonate or the reagent other than the acid, because you don't want any of the acid to remain. You want all of it to get used up, and for that to happen you have to add excess of the other reagent. So you start with an excess of copper carbonate. You add it to the acid. So a reaction takes place and all of the acid would be used up. However, some of the solid, which is copper carbonate, would remain, and you need to separate this from the solution, which is your product. And to do that you need to filter out the mixture. So you now have the filtrate, which has the product, which is copper ethanoate, but this is in liquid form, so you need to crystallize it. And to do that you need to heat the filtrate. So you observe crystals forming on the dish in which you're heating the mixture. So you heat till crystallization point, and then you let it cool, and you let it cool down so that crystals can form. 3. Write the word equation for the reaction between ethanoic acid and copper carbonate. This is a metal carbonate and an acid, which gives a salt, carbon dioxide, and water. So I'll be writing carbon dioxide over here because I don't have enough space. (5a) Nickel iodide crystals are hydrated. A sample of hydrated nickel iodide crystals has the following composition by mass. So 14% nickel, 60.33% iodine, 2.85% hydrogen, and 22.81 oxygen. Calculate the empirical formula of hydrated nickel iodide crystals. So to write the empirical formula, you start by writing down the symbols of the elements found in the compound, and then you write their mass or composition, percentage composition. 60.33, 2.85, and 22.18. So you can use this percentage composition to find out their number of moles, and so you divide the percentage composition of each of the elements with their respective atomic masses. So nickel has atomic mass is 59, iodine is 127, hydrogen is 1, so you don't really need to do anything over here. Oxygen is 16. So this gives the answers of moles as 0.237 of nickel and 0.475 iodine, 2.85 hydrogen, and 1.426 oxygen. Now you need to find out the ratio of this, and to do that you need to divide all of the values with the least value over here, which is 0.237. And when you do that you get the ratio as 1 for nickel, 2 of iodine, 12 of hydrogen, and 6 of oxygen. So the formula is Ni, I2, H12, and O6. Molten nickel iodide can be electrolyzed using the apparatus shown. During electrolysis, charge is transferred through the copper wires and through the molten nickel iodide. 1. Name the type of particles which transfer charge through the copper wires. So copper wires conduct electricity by the transfer of electrons, and that is why the charge over here is electrons. 2. Name the type of particles which transfer charge through the molten nickel iodide. So these are ions. 3. Predict the products of the electrolysis of molten nickel iodide. Write an ionic half equation for the formation of one of these products. Alright, so since this is a molten mixture, you don't have a solution. That means the only ions over here are going to be nickel ion and iodide ion, which means nickel and iodine are going to be the products which deposit at the electrodes. And I'm going to be writing the half equation for nickel. You can write for iodine as well. I'll be explaining both of them. Right. So to start with, as you can see over here, nickel has oxidation state of 2. That means its ion has a charge of 2 plus. And so you need to cancel out this charge. You need to make it to 0. And to do that, you need to add 2 electrons to cancel out the positive charge. So you add 2 electrons and this forms a nickel atom, a neutral nickel atom. And as for iodine, each iodine ion has a charge of -1 and you need to cancel out this charge. So you take out electrons. To cancel out one charge, you take out 1 electron and this gives an iodine atom. However, iodine exists in a diatomic molecule form. So if we need to have 2 iodine atoms as the product, we need to have 2 iodine ions to start with, which means the overall charge would be 2 negative and 2, so you need to take out 2 electrons. See, a student electrolyzed copper sulfate solution using the 2 sets of apparatus shown. So in one of these you have carbon electrodes and in the other one you have copper electrodes, and rest of the apparatus is identical. In apparatus A, the student used, so that's mentioned. The student made the following observations. Apparatus A, the mass of, let me just explain this process over here. The first apparatus A is used for electrolysis of a typical solution, a metal solution. So we have the ions, the copper ion. The cations basically are going to be copper, hydrogen, and then the anions are sulfate ion as well as hydroxide ions. So the cations, which are the positive ions, attract toward the negative electrode, which is cathode. However, the more reactive of the two remains in the solution. It remains as the cation, and the less reactive of the 2 ions is deposited at the cathode. So in this case, it's going to be copper. However, for anode, we have, so we have 2 ions, 2 negative ions or 2 anions. And for anode, the case is opposite. The more reactive of the 2 is attracted. Well, both of them are, but the less reactive ion it remains back in the solution, and the more reactive ion is deposited at the. But in here, this apparatus B is carrying out a process similar to that of purification of copper. So the mass of positive electrode or anode would decrease as copper from anode would form copper ions in the solution, and then those same copper ions would be used on or deposited on cathode. So the mass of cathode would increase, mass of anode would decrease, but the concentration of copper ions in the solution would remain the same. Since the ions deposited over here, or the copper metal deposited over here, does not use copper ions from the solution. It uses copper metal from this positive electrode. The mass of positive electrodes stayed the same. Bubbles were seen at the positive electrode. So negative electrode is the cathode, which attracts positive ions. As we discussed earlier, copper would be attracted. Since copper gets deposited on the cathode, its mass increases. The positive electrodes stayed the same because hydroxide ions give oxygen gas in the form of gas, and that does not cause any increase in mass of anode. However, it does form bubbles, which are observed. 1. Explain why the mass of the negative electrode increased in both sets of apparatus. Alright, so over here as well, we discussed that mass of cathode would increase because copper would be deposited. And in both of these cases, it's copper metal which causes increase in mass. To name the gas that formed the bubbles seen in apparatus A. So this was oxygen from the hydroxide ion. 3. Explain why the mass of positive electrode decreased in apparatus B. So the copper from anode over here changed to copper ions in solution, and then those ions were deposited as copper metal on the cathode. And that is why the mass decreases. 4. Suggest what happens to the color of the solution in apparatus A and apparatus B as the electrolysis progresses. Explain your answer. Alright, so as I mentioned over here, as we discussed over here, copper ions from the solution are converted to copper metal, and initially the reaction would have been blue in color, but which is due to the copper ions. But since they no longer remain after the electrolysis has been completed, the color of the solution would turn colorless. The color would turn colorless. It would no longer remain blue. However, in apparatus B, since the concentration of copper ions in the solution remains the same, the color does not change. So that is going to be the answer. A becomes colorless. Color of solution in apparatus B. Alright, so this remains the same. And you can give explanation for either of these, since this is only 3 marks, one for each of A and B, and the last mark for one explanation for either one of them. So I'll be giving explanation for the apparatus A. So copper ions are removed, but they are not replaced in apparatus B, and that is why the color fades. You can also write for B that copper ions are removed and added back at the same rate. So they are removed when they are added when copper turns into copper ions in the solution, and then it's taken back or removed when copper ions form copper metal. So overall the rate is equal, which means there is no change in color. 6. Calcium chlorate is made by reacting calcium hydroxide with chlorine gas. A 8.8 grams of calcium hydroxide and 7200 cm³ of chlorine gas are mixed together. How many moles is 8.88 grams of calcium hydroxide? So you're given with the mass, and you can calculate the molecular mass of calcium hydroxide, which is you need to add the relative atomic mass of calcium and the hydroxide ion in this compound, which is going to be 40 of calcium. And since you have two hydrogen atoms and 2 oxygen atoms, there's going to be 2 into 1 for hydrogen plus 2 into 16 for oxygen, and this means the molecular mass is 74. Now you divide the mass given in the question with the molecular mass, and this gives the answer of moles as 0.12. How many moles of chlorine gas is 7200 cm³? Alright, so this is a gas. You're given with its volume, and to calculate the number of moles, you divide it with the molecular volume of any gas, which is 24,000 cm³, and this gives the answer as 0.3 moles. 3. What is the maximum number of moles of calcium chlorate that can be made from 8.8 grams of calcium hydroxide and 7200 cm³ of chlorine gas? Alright, so the equation says 6 moles of calcium hydroxide and 6 moles of chlorine give 1 mole of calcium chlorate, and you need to use the equation, the ratio set in the equation, to derive the number of moles. that will be given in this reaction. So now you need to use the moles of calcium hydroxide because as you can see over here, there's 0.12 moles and 0.3 moles of chlorine and 0.12 moles of calcium hydroxide. In such cases, when you're given 2 moles and you need to use either of them to derive the number of mole of another substance or another compound, you use the one which is the limiting factor, the one which is of less quantity. So I'm going to be using 0.12. So we have 6 moles of calcium hydroxide gives 1 mole of calcium chlorate. So that means how many moles do we gain from 1.2 moles? So this is x over here. You cross multiply them. So 6x is equal to 1.2. You divide both sides by 6. And so x over here is equal to 0.02 moles, which is the number of moles of calcium chlorate ions. 4. What is the maximum mass of calcium chloride that can be made from 8.88 grams of calcium hydroxide and 7200 centimeter cube of chlorine gas? So now you have the number of moles of calcium chlorate. You can calculate the molecular mass and then use them to find out the mass. So the molecular mass of calcium chlorate. Now we can use the formula mass is equal to number of moles into molecular mass to calculate the mass, which is 0.02 into 207. So that would give you the value as 4.14 grams. The experiment is repeated using different amounts of calcium hydroxide and chlorine gas. The maximum mass of calcium chloride that can be made in the experiment is 4.84 grams. So this is the expected or predicted yield. 5. The actual mass of calcium chloride made in the experiment is 3.63 grams, which is the actual yield. So calculate the percentage yield. So you have the formula actual yield, which is 3.63 divided by the predicted yield, which is 4.84 times 100. And this gives the answer as 75%. B. Calcium chlorate undergoes thermal decomposition. The only products are calcium chloride, and a colorless gas. What must be done to calcium chlorate to make it thermally decompose? Well, you must heat it because this is thermal decomposition. 2. Write a chemical equation for the thermal decomposition of calcium chlorate. And you need to balance out the number of oxygen, which was 3 2s are 6 over here, and you write a 2 over here, 3 over here, which balances the numbers. 6. Chloric acid is a strong acid. It can be made from calcium chlorate. 1. What color is methyl orange indicator in chloric acid? So that is red. 2. Define the term acid in terms of proton transfer. An acid is a proton donor, since it donates a hydrogen ion, which can also be defined as proton. 3. Complete the chemical equation to show how chloric acid behaves. Right, to show chloric acid behaving as an acid in water. So you have the chloric acid, and once you dissolve it in water, it dissociates into ions. So you have the hydrogen ion and then the chlorate ion. So over here you have the chlorate ion. This has lost a hydrogen or a proton, so this would then gain a charge of -1, since -1 over here and -1 over here and +1 over here originally cancelled the charge, and the compound would have an oxidation state of 0. But if you remove a proton from it or a hydrogen ion from it, the charge would be -1, and this proton is then accepted by water, which is acting as a base, and that would be H3O. And since you added a positive hydrogen ion or a proton to a neutral compound, the oxidation state would increase by 1, and so it would gain a charge of plus.